Hello and welcome back to Azure Terraformer. Today we're going to continue our journey working with the Azure Monitor diagnostic settings. This time we're going to extract that into a reusable module to cut down on all the extra code, make it a little bit cleaner, and to simplify how we attach diagnostic settings to our resources going forward. We're also going to be using dynamic blocks today to clean up the diagnostic setting, because that one of my biggest pet peeves with Terraform blocks is when you have a resource that was designed like Azure Monitor to have n number of these repeating blocks, it can get way too verbose, in my opinion, where if you have like 8 or 10 different log tables, that diagnostic setting gets really nasty really quick. So declaring an array of those tables and passing that into a module creates a much cleaner and easier to use interface for developers that are trying to work with Azure Monitor diagnostic settings. So without further ado, let's get coding and let's create that module. So I'm basically in Terraform, a module is really just a folder. A folder defines the scope of the module, and anytime you run Terraform init in a folder, that folder becomes the root module. You can define additional modules that are then referenced and reused inside that root module. But you can think of the difference between a root module and a regular, like, reusable module is that the root module is the thing that you're gonna run Terraform plan and apply in that folder. And it's basically gonna be where you deploy from, where you provision from. Reusable modules are designed in such a way that you don't actually run Terraform plan in that folder. So we'll get started here. So I'm just going to create a folder called modules, and I'm going to create a folder called diagnostic setting. Okay. Now I'm going to have many of the same files, but they're going to be slightly different. I need a versions, I need a variables, I need a main. And in versions, unlike our root module, we do not want to declare a provider, and we do not want to declare a backend. But I am going to grab the required providers block, and we are going to drop the backend. And we do not need random. And instead of using the arrow, I'm going to say greater than or equal to 3.41. So this is an important caveat. It, rather than having an opinionated specific version that you want to use, this allows us to use version 3.41 or greater with this module. So it's kind of a good thing to have. My main module is where I'm going to start. I find it easier when extracting a module to just take my code that has a bunch of hard-coded values in it, and then to just paste that into the main. And then this is where I'm going to start decomposing it into and replacing those values. So I know that I'm going to need a name, var.name, and in my module, so I'm just going to declare my module. So this is my key vault diagnostic, and then the name is going to be that, and we need a variable for name. And then we're going to have a var resource ID, and that is going to be, so you can kind of see like how I'm in doing two things simultaneously here, right? I am, number one, working on the module code, the diagnostic setting code, but I'm also working on a reference to that object. So when we declare a module, we give it a name, just like in Terraform, when we declare a data source or a resource, except we don't need to specify the type of the module. Rather than having the type embedded there, we actually have to specify the source for the module. So in this case, it's going to be a relative path, and IntelliSense picks up that folder, and there we go. So this is going to be the source of my module. It's local within this code repo, and then we basically pass in any of the input variables that we declare. Okay, and I'm stubbing them out right now. I haven't declared these variables yet, so I'm using them here, but I need to declare them as well. We'll do that in a little bit. But I want to get the values that I pass in here because I don't want to have to go figure it out later. I've already figured this out. I don't want to go figure it out again. Now, the reason why this will not work inside here is because the scope of this module does not actually have a Azure storage account data source called observability. That is in the scope of my Terraform root folder. This thing, I cannot reference this when I'm in this modules diagnostic setting folder, even though it's nested within that same folder. The Terraform module is scoped to whatever folder that you're in. So any Terraform file in that folder, you have scope line of sight to. Anything outside of it, you do not have scope access to. It's not visible to you at all, and it must be passed in as a variable input, as an input variable. This scoping decision, I think, makes Terraform very, very simple. It's a simple machine. You have inputs, you have outputs. That's it. You have one folder, and any Terraform file in that folder is fair game. You have inputs, you have outputs. So there's no cascading effect going on here. Storage account. And so here I'm going to declare a storage account ID. And here I'm going to set my log analytics workspace ID. Now, dedicated, I'm going to leave hard-coded here. This is the opinionated nature of this module. This module, it's okay to hard-code certain things in modules. When we say a module should be opinionated, that means that that module can have certain design patterns or implementation details built into it that are unchangeable by an input variable. Resources are designed to be extremely flexible, but modules is where you can bake in some some certain way of doing things. How about that? It's okay to do that in a module, and you shouldn't feel bad about doing that. It does limit the flexibility of the module, but in certain cases, and in this case, I don't want to have the flexibility to change this from dedicated to something else. That's the way that I want it, and I want it to be that way always. Anytime somebody uses this module, we want to use dedicated for the log analytics destination type. So we're just going to hard code that. Now these values here, right? I've got audit event. So now the structure for this, what I want to do is I want to pass in an array. And this is where I'm going to change the structure. I want an array of strings, and oops, one of them is going to be audit event, and one of them is going to be Azure policy, whatever, details. Okay, wonderful. And then I want my metrics to also be an array. And I'm going to go grab all metrics, and that's going to be the value that I use there. All metrics. Wonderful. Okay, so now I got to commence with the dynamic block. So for my dynamic block, I've gone over this in a previous episode. I think this is my first mailbag episode. The way I like to do dynamic blocks is just like I did with the module. I'm gonna take the existing code, I'm gonna leave it in place, and I'm gonna modify it while I'm looking at it. I'm gonna rewrite it essentially while I'm looking at it. So when I use a dynamic block, I'm basically gonna say dynamic. I'm gonna declare a dynamic. The block name is enabled log, and I'm going to for each. You know, this feels very unnatural, you know, as a C# developer. You know, for each is not supposed to look like this. I'm going to declare a content block so that as I iterate through each item in this array, I'm going to create this content. Now the content that I'm going to create is right here. So basically the content block here maps to this enabled log. And so this curly bracket here corresponds to this curly bracket here. This curly bracket here corresponds to this curly bracket here. So all this stuff inside here is what I want to be inside my content block. So I can put that in there. Now I clearly don't want to have audit event hard-coded in here. I could, then like for every item in my array, I'm going to have an audit event category, but that's not what I want. What I actually want is I want the item in this array, which is going to be on this enabled log. In order to access the item of my array that I'm iterating through with the for each, I have to reference the dynamic object itself. So I'm going to say enabled log dot value, and that's going to get me the current as I'm looping through this for each loop. Each item in this array is going to, at some point in time, going to be this value. So if I have 3 items in the array, the first time the value is going to be the first item, the second time it's going to be the second item in that array, and the third time will be the third item in that array. And so that's how I can get the value. Now for the retention policy, this is where I probably want to change some things about my module. So if I go back and I look at, let's just smash the back button. Oh, went too far. So retention, if I go look at retention policy, so the retention policy block just enabled. Oh, so I can have number of days. Okay, so on my retention policy, I'm going to set the days. Enabled will be true, and then days will be set. Now I'm going to add a variable called retention in days, and that'll be a number that I set. It could be 7, 30, 365, 90, whatever I want it to be. Okay, but that's what I want it to be. So I think I got too many tabs here. It's not going to be happy. Terraform likes 2 space tabs. Okay, so there we go. And you know what? I don't know. I can just call it the retention period, right? Retention. Whoa. Retention period. There we go. Okay. So now with my retention period set, okay, now I can delete this enabled log because I don't need that anymore. And now I can copy this dynamic block because it's going to be pretty much the same thing for metrics. I'm just going to change that to metric, change that to metric, and change this to metrics. Yep. And I think that should be exactly the same. So now I've got my dynamic metrics and I've got my dynamic enabled logs. Now my variables. This is where it becomes fun. So I need a variable for name. I need a resource ID. What else do I need? I need a storage account ID. I need a log analytics workspace ID. Yep. I need a logs array. So that'll be, I think, list of string. And then I need an array of metrics, list of string, and then I need a retention period. Let me just go grab that. And that will be a number, I believe. Very good. And I think those are all the values that I need to construct this diagnostic setting. And notice I named my diagnostic setting domain. When I am scoped within this module, basically the name of this object reference can be relative to the module itself. This module itself, its sole purpose in life is to deploy a diagnostic setting. So why would I call this diagnostic setting? You know, that's, or key vault diagnostic setting or whatever. Like this is the main resource that we're deploying with this module. So I can just call it main, right? So this is kind of the relativistic naming strategy that I use with Terraform. If there's only one thing, I'm just going to call it main, and that's my main thing. That's my main squeeze. That's my main resource. I don't have a second. I don't have a third. That's all that I'm doing. So yeah. Now I need to set my retention period here, and we're going to set this to what? 90. Let's set it to 30 days, just for fun. Okay. There we go. All right. So my module is called the Key Vault Diagnostic. Inside that module, there's going to be a diagnostic setting resource that will have a name of main. Okay. So I think this is good. So refactor with module. So now this is the sad part. When you refactor and encapsulate something into a module, the original thing that you created using a resource is going to get destroyed. Why? Because the path in Terraform state does not exist inside a module, right? Whenever you wrap a resource inside of a module, the path to that thing in Terraform state changes, even though it's the exact same thing. Like I don't think I've changed really anything about the diagnostic setting at all. But the fact that it's now in a layer of a module, Terraform Terraform thinks that the old thing is gone, and it needs to destroy it and create a new thing, which is what we're seeing here. So our old not in a module resource is being destroyed, and then our new in a module thing is being created. And you can see like the path is module key vault diagnostic setting .main. So we've got the module key vault diagnostic. That's the name object reference of the module. Then this is the resource type, and then this is the object reference of the resource within the module. So again, you can see why we don't need to have diagnostic setting again on here, because we have the type here and we have the name of the module object there. So we're just fine. And we're creating this thing with 30 days. So our dynamic blocks are all working. It's just, we're going to have to delete and recreate. That's kind of the nature of the beast. So I'm going to approve this. And we are going to use our module to deploy that diagnostic setting. And we have a failure here. The resource ID, you know what? So the uniqueness of this diagnostic setting failed because we're like the name, I'm using the same name. So let me go check what I have deployed. Let me see if this key vault has a diagnostic setting out there right now. So this can happen when you drop create like this. It gets upset. It gets upset. I'm guessing if I rerun this, it's just gonna be fine. But I think what was happening was there's a little bit of a race condition between deleting the diagnostic setting with the same name as the diagnostic setting that we're trying to create. Because we can't use a depends on in that situation, because we're literally going to delete the thing and then create the new thing. But because the new thing has the exact same resource ID as the old thing, we have big problems. But we can't use depends on because the thing that it is literally dependent on is about to be deleted. So this is, chalk this up as a transient Terraform error. And it happens when you are, in this case, I'm refactoring, moving that same diagnostic setting into a module, making no changes to it other than the structure of the code. I suppose I did change the retention period, but I don't think that would be an attribute change that would cause a replacement of that resource. So let's go look at the plan. So the plan this time, we're probably not destroying anything, we're just creating. So last time when we failed, we were trying to destroy and create simultaneously, and the path of this thing, I guess it's known after apply anyway, but the path would have been identical. Yep, and you can see we're successful now. So yep, absolutely transient failure, solved by running 2 Terraform applies. So there we go. So we refactored our Azure Diagnostic setting, and we made it a much more concise module block, instead of that very verbose repeating block of logs. we can just pass in an array of log categories, and an array of metrics, and give it a retention period, and we're good to go. So I hope you can see how the modularity capabilities of Terraform can make it extremely efficient and productive for you to encapsulate your opinionated best practices into those modules, and then reference them from your regular Terraform that's tied to your applications, your APIs that you're trying to provision infrastructure for, such that you don't have to copy pasta that everywhere. We have a place, albeit right now just in this repo, where we can pull this module and reuse this implementation of a diagnostic setting over and over again, and take advantage of this really nice interface. Next episode, I'm going to show you how in Azure DevOps we can create a private Git repo in Azure DevOps, and we're going to reference this module that we host in a separate repository on Azure DevOps. And so this is where you can get a lot of power as an organization. You create a Terraform module repository where you compile a huge number of these modules that have your enterprise best practices infused in them, and then you can reference them from all your different application projects. So as opposed to retroactively enforcing policy, those policies can be built into what your developers go provision when they stand up projects from the get-go. So next episode, we'll tackle that. This episode just wanted to introduce some module refactoring, extraction, and some techniques, and why modules are good, and why you should learn about Terraform modularity and use it within your Terraform projects. Anyways, I hope you found this useful. If you did, smash the like button. If you haven't subscribed yet to the channel, please do. I am trying to get to 1,000 subscribers so that we can do some live streaming stuff on YouTube, where we can really engage with the community and have a good old time on the weekends and stuff, where we just sling code and we do things live together. So please hit subscribe, and it'll really help the channel out. And once you do, ring that bell so that you know when my next video drops. I'm pumping out videos 2 times a week, Tuesdays and Thursdays. So always be aware of when my next video drops by hitting that bell. Anyways, that's it for me today. This is Azure Terraformer signing off.